consider a small part of this loop or the coil. Small part if you are considering here also part of one wire only. Suppose this is maybe. So what is the distance here? Distance will be the radius of this loop. Suppose it is A. The current element is in this direction. This is suppose I delta L. I is small I we have taken. So I delta L is the current element. Angle between this current element and this, as we are interested to find the magnetic field at the center. So angle between this current element and this radius vector is 90 degrees. So magnetic field at the center of loop or coil due to current element IDL or I delta L we have taken. Delta L will be how much? So this delta V, if you are giving the symbol, so delta V at the center will be mu naught over 4 pi. If it is in air, if any other medium, then mu naught mu r will also come. I delta L sine 90 will come. Angle between this and distance, square of the distance will be A square only. Now, if we find the total magnetic field at all the current elements, suppose large number of current elements we are considering. So, what is the difference? Means variable. I will be same, A square is same, sine 90 0 1 only. So, only variable is delta L. So, delta L will keep on adding. So, if you find magnetic field due to the whole loop or coil, then simply, so it is simply mu naught over 4 pi I over A square is out and delta L is only, if you want to integrate, we will write dl, then we will integrate. If you do the summation, we can write delta L. So magnetic field at the center of the loop due to whole loop or coil. This B will be how much? It will be mu naught over 4 pi I over A square, maybe summation of delta L we are writing, or if you have writing integration, if you are taking dl small length, then we will integrate it. So integration of dl or summation of dl, if you are interested in integration, then what will be? You will take this one, dl only. Then here also you have to change. This will be I dl, you have to take previous step. Also you have to change dl. So what will come now? Mu naught I over 4 pi A square. Total length, if it is loop, then simply 2 pi A, the complete loop is there, then 2 pi A. In case of coil, it will be 2 pi A n. If suppose only half is there, then n will become half, 1/4 loop is there, n will become 1/4. So general formula what will be? This will become 2 pi A into n. Whether you are doing integration or summation, no problem. Because only variable is the length. So we will take total length. Now what will come? So this B at the center will be mu naught 2 pi 2 times A cancel. So mu naught N I over 2A. This is the magnetic field at the center of the coil or loop. In case of, if the number of turns is more than 1, value of N will be more than 1. If only suppose half loop is there, like this it is. So current is coming this way and it is going this way. Then this N will become half. So we will use this formula only when you are asked to find magnetic field at the center. We will use the same formula, value of N will become half. If only 1/4 is there, suppose the current is entering from here and leaving this place like this it is. So then N will become 1/4. So the same formula is applicable for loop or coil when we are considering at the center. Okay. Now other is magnetic field intensity at any point on the axis of circular coil. At any point on the axis of circular coil. Suppose this is a circular coil or circular loop. After giving so many rotations, suppose the current is coming out. Maybe like this it is, okay. So this is the axis. So coil is in this plane, suppose. Here is the coil. And the point is like this here. Axis is this one. We are interested to find the magnetic field at this particular point. Okay. So in this case, each point or each element, what we are going to consider, will be equidistant. Okay. So whatever point you are considering, suppose this is the circular loop or circular, we can show, okay. So suppose this is the coil. This is the axis. Now the distance of this point from this one, from this one, from this one, from here, everywhere it will be same. From this point or from this point or from all the points are equidistant. So this distance will be same for all the elements. Elements are here along this one. Elements are present and distance of this particular point P where we are considering will be same. And how much will be? If this distance is suppose R, this radius of the coil is A, then this S will become R square plus A square under root. Sometimes that S will be given, sometimes R and A will be given. Now, if suppose this is the element we are considering here, and this is the distance, this way. So angle between this element and this one, position vector. Element is along this tangent. Position vector is along this axis. So angle between the tangent and this radius vector or position vector will be 90 degree. From anywhere. Here, anywhere you can consider. So this is in this plane. This is.
Sir, once again, sir.
Yes?
Once again,
So,
sir.
angle between the current element, as the current is passing suppose clockwise. Current element is this one. This is the direction along the finger. Current element, if the current is clockwise, current element this one. Whereas this position vector is this one. So angle between this finger and the marker. What is the angle? 90 degree.
Yes, sir.
Anywhere you take. This one here, current element this one, this is the direction. So angle is 90 degree. Angle between current element and this position vector S is 90 degree. So if you consider an element here, IDL or I delta L, whatever you consider, what will be the magnetic field? So we are considering a coil of number of turns N, radius is A, let the current I be passed, and the current is here in clockwise direction. Okay. We can assume anti-clockwise also. So when it is clockwise, naturally magnetic field direction will be different. Anti-clockwise magnetic field will be opposite. So what will be the magnetic field intensity? At P due to current element IDL, or you can consider I delta L, no problem. So this dB, if you have considered dl, then you will write dB, delta L, then delta B you will consider. So what will be this? Mu naught over 4 pi I dl, distance is s square, and angle is 90 degree. Yes, any confusion here? Angle between current element and this position vector is 90 degree. Current element along this finger and position vector is along the marker like this. So they are perpendicular, whether it is here, anywhere. This angle is perpendicular only because they are in different plane. So marker will always be perpendicular to the finger. Okay. Now, what is the direction of this field? So suppose this is the current and this is the position vector. So direction is what? IDL cross, here it is S. So IDL cross S. IDL like this, cross S this way. So it is inward. What perpendicular to this? As this is inclined, so perpendicular to this. If it is like this, then perpendicular like this it will come, but it is not horizontal. It is inclined. So perpendicular to this it will go. So this direction of this magnetic field will be making an angle of 90 degree from this one. Okay. So it will make an angle of 90 degree from here. If this angle is theta, then this angle will be theta. Is there any confusion? Yes? This angle is theta, then this will be theta. From here to here is 90 degree. And this also 90 degree, no? This also 90 degree. So this plus this 90, naturally this plus this will be 90 degree. Okay, so this is theta. Now if we break this dVH component, then what will come? dV cos theta will be this side and dV sin theta will be this side, or delta V if you have considered, then delta V. Now, if we consider a point diametrically opposite to this, that is this point, due to this current element, what will be the magnitude of the field? Same as this one. What is the direction? It will be perpendicular to this line, 90 degree to this line. This is again dV. Magnitude will be same. Direction will be perpendicular to this line. Now, if we break this one as component, this is again theta. So this is dV cos theta, and this one will be dV sin theta. So what we are going to show, or we want to show, is this dV cos theta will be cancelled. Each point has got diametrically opposite point. No? Magnetic field due to this and this, equal and opposite. This and this component will be equal and opposite. This and this, same. This and this, same. So this component, the net field, vertical component will become 0. So we will have net field towards the center if the current is clockwise. If the current is anti-clockwise, away from the center. Because in that case, this dV will not come here. This dV will go that side. One component this side, one component this side. So away from the center it will come. So dV cos theta will be cancelled. So net field at point P, net field due to this coil, at point P, this B will be what? It will be mu naught over 4 pi, this is constant, I over S square constant, integration of dl cos theta. Or total loop we can say, or this one will, okay. Now this cos theta is also same. So cos theta also we can take outside, no problem. No, cos theta will cancel, no? Sin theta, sorry. So I sin theta and integration of dl. Because this dV cos theta will be cancelled, dV sin theta will be left. Now if we do the integration or summation, whatever you do, again same thing. What is the dx dl? 2 pi a into n. So this is mu naught over 4 pi I over S square sin theta 2 pi a into n, where n is number of turns in the coil. So this B will be mu naught by 4 pi I. In place of s square, we can write r square plus a square. Okay, afterwards we'll write I over s square sine theta. 2 pi n will cancel. Okay, what will come? 2 pi will cancel 2. Will it be this? So mu naught ni a over 2s square. Is it correct? Okay. Now we'll substitute the value of this sine theta. This sine theta will be, this is the perpendicular, this is the hypotenuse. So in place of this, it will come mu naught ni a over 2s square into a by s. Mu naught ni a square over 2s cube. Mu naught ni a square over 2 a square plus r square to the power 3 by 2. So this is the general formula for magnetic field due to coil. We can use this to find the at the center also. So what will be magnetic field at the center?
R equal to 0.
So at center, okay, for magnetic field at center, what will be? This R will become 0. So what is the value B at center? This will become a square to the power 3 by 2, that is a cube, a square by a cube. A only, so this is mu naught and R over 2a. So same formula which we have derived there. Now other condition is if R is much more than A. The point P is very far from the center. So if R is much more than A, then what will you use? Then this R square plus A square will approximately R square. So A will be negligible then. Then what will be the magnetic field? Mu naught N I A square over R cube. 2R cube will come. Is it correct? Okay, so this will be the general formula for magnetic field at any point on the axis.
The time is up, sir.
What time